Welcome, Hornets. In this video, we're going to be talking about the second derivative test. And the second derivative test involves derivatives that or critical values and concavity. So I want you to notice right up here we have a relative maximum, and here we have a relative minimum. I've identified both of these as critical values on F. As noted by f of x having horizontal tangent lines at C and D. And what I want you to notice is that the concavity of f of x is concave down from 0 to a. So here we have f of x is concave down on 0 to a. Notice right here, f of x is concave up on A to B. And it's important to recognize that we do have concavity over the entire interval. And that's important around the relative extrema that we're considering. And the second derivative test says this: if there is a critical value at C and f of x is concave down at that critical value, then f must have a relative maximum at C. If f of x has a critical value at D and f of x is concave up at D, then f of x must have a relative minimum at D. And this is what logic dictates. If I have a maximum, I have to be at a critical value. But in order to have a maximum, I have to have a concavity that is concave down over the entire interval. Same thing with a relative maximum. Concave up around the critical value will force a relative minimum. If f of x has a critical value at x equaling c, and the concavity of f at x equals c is concave up. Let's go concave down. Excuse me. I.e., f double prime of x is less than 0, negative, then f has a relative maximum at x equals c. If, however, which you can see that, f of x has a critical value at x equals d, and the concavity of x cavity of f at x equals d is concave up, i.e., f double prime of x is greater than 0, then f has a relative minimum at x equals d. So once again, the second derivative test requires that there is concavity and requires a critical value. So we have to know at a critical value where the first derivative is 0 and the second derivative is either positive or negative at that critical value will immediately determine whether we have a maximum or a minimum. And this can sometimes be very helpful to us. So once again, we'll see this when we're working with curve sketching. So please keep this in mind, and I hope this helped. Thank you very much, Hornets. Please be well and be safe. And in the next video, we will be talking about curve sketching. Thank you very much. Be well and be safe.